Okay. Sorry about that, it got disconnected. Okay, hopefully it won't happen again. Let me check. Yeah, sorry for that. Okay, so it got disconnected and we were discussing the question about the pendulum, and okay, so we are given that our r is the radius, so r is our radius of earth, and it is also given that the horizontal displacement, that is our d upon re, is very much less than 1. So we are given that the horizontal displacement, that is d upon re, is very much less than 1, or we can say that d is very much smaller than our re. Okay, so this we can draw from here. And theta naught is the angle subtended at the center. So we can say that our angle subtended at the center is our theta naught, and theta naught is approximately given as d upon re, which is much less than our 1. So this is our given to us. And let's find out what will be the various forces on the pendulum bob. Okay, so this is the pendulum bob. And this is the earth, and the pendulum bob is this one. So you can see the forces on the pendulum bob. Forces on the pendulum bob. Okay. First of all, the first obviously will be our mg, that will be towards the earth center. So we are going to have our gravity, that is our Fg, which is our mg, and it will be radially towards the center. We can say radial towards center, and there will be also pseudo force that will be acting on it. So we can say that our pseudo force, and that will be due to the horizontal acceleration A, which we have provided. Okay. Pseudo force due to the horizontal acceleration which is given as our A. Therefore we can say that our Fp will be equal to, that will be mass into acceleration, but with negative sign, that is in the opposite direction. Therefore we can say that the effective force in the pivot frame effective force in the pivot frame. The pivot frame, and let us call this as our F, and F will be equal to our Fg plus our Fp, and we can find out their magnitude. So we can say that our F magnitude, we can substitute the values. Fg is our mg square plus Fp is our minus of ma square and its square root. This comes as our m square root of g square plus a square. Okay. So this was our you can say the effective force, and obviously we can say there is a small angle direction. And for direction, you can write that our tilted backward or we can say opposite acceleration by small angle phi, Therefore we can say that our tangent of phi will be equal to A upon G. And now we can find out the equation for the motion of the pendulum, which we have already know how to solve it. So we can write that our equation of motion of the pendulum and this we are given that if the length of the pendulum is capital L, that is measured from the pivot to the bob, then there will be a torque acting on it, and that will be a restoring torque. So in that case, let us draw the basic figure, and okay, you can say for pendulum length is equal to L, then the torque about the pivot will be equal to distance, and that will be equal to over m g effective sine of theta. Okay. G effective we have already drawn here. Okay. And this G effective we can divide it into two components, okay, and that will be our G cos of theta as well as G sine of theta. Okay. And so we can this is our effective and this is our theta. So our two components we can find out this will be our mg effective sine of theta, and this will be our mg effective cos of theta. And the torque will be our restoring, so we can put here negative sign. Once again, sine of theta, this theta is small, so we can put sine of theta is equal to theta. And we can write that this is the equation of the torque, so this will be our tau. So we can say the rotational equation for our motion. We can say rotational equation will be our I double derivative of our theta will be equal to our minus L mg effective sine of theta is our theta, and moment of inertia, that is our ml square. So we can say we substitute I is equal to ml square, we get this as ml square double derivative of theta is equal to minus L m g effective times theta, and here this square goes by L, mass goes by mass. Therefore we get this equation will be equal to our double derivative of our theta plus this will be g effective divided by L times theta is equal to 0, which is nothing but our standard equation of our SHM, which is theta double dot plus omega square theta is equal to 0. So if we make a comparison, we can say that our omega is equal to our g effective divided by L and its square root, and we can put our g effective. So we get W is equal to G effective is equal to G square plus A square and square root L, and this comes as 1 by 2. And if we assume that our A is very much less than G, therefore our omega will be approximately equal to G upon